Hello, everybody. How's it going? Reed here. Today, we're going to have a very interesting discussion today. It's going to be on the orbitofrontal circuit, orbitofrontal cortex. This is a very important circuit in the brain. And it's important to sort of understand these different circuits and what they're responsible for. And most importantly, you want to know the receptor profiles on them, right? If you understand the receptor profiles on the circuits, then basically you have an idea of the most effective medications you can use to manipulate those circuits, right? After all, I think that's all what we do. We're sort of like engineers, and we sort of manipulate the circuitry of people. Hey, Max, how's it going, buddy? Good to see you, man. Um, we sort of, and so here we're going to be talking about the orbital frontal cortex today. Let's see, later on my series of narcissism is a network. So the series Narcissism Network, I'm starting a new series on parental alienation. And so I'm going to be talking about this series is going to focus on the very noticeable high-profile cases of parental alienation. And so this basically shows how narcissists work as a group, and basically, when you're in contact with a narcissist, you're basically under attack by a network, right? And so with parental alienation, basically, a network is turning your child against you. So it'll be very interesting. Also, yesterday, I did a lecture on the dorsolateral prefrontal cortex. This is a very important circuit to know. The dorsolateral prefrontal cortex is thought to be the location of the ego. Yep, the mythical ego, I believe, is located in the dorsolateral prefrontal cortex. And I think they're right. Malfunctioning in the prefrontal cortex causes significant disturbances in reality. And I'll show you how. It makes sense how. So none of the stuff is like mystical anymore. Also here, the neuropsychiatric manifestations of HIV disease. This will be interesting too. So let me go ahead and get started. Okay, so let me do chat. Okay, let me see chat GTP. Okay. Explain the orbital frontal circuit. See what we'll get here. The orbital frontal circuit, also called the orbital frontal subcortical circuit or the orbital frontal cortex loop, okay, is one of the major frontal striatal networks in the brain. This is the networks that connects the frontal lobe to the striatum, the deeper parts of the brain, that eventually gets connected to the hippocampus with the thalamus, which is the relaying signal for the brain. It's one of the major frontal striatal networks in the brain. It plays a crucial role in, emotional regulation, impulse control, reward-based decision-making, and social behavior. So remember, you run into people who may have like emotional difficulty controlling emotional, so very labile mood, unpredictable mood, impulse control issues, decision-making problems, social behavior issues. Think about this orbital frontal cortex, right? And then we're going to go through some of the pathways, some of the receptors on it also. So you know what medications can impact it the most, right? So look, anatomical and network layout. The orbital frontal circuit connects the orbital frontal cortex, located on the ventral surface of the frontal lobes, just above the orbits of the eyes, with deep cortical structures through the closed loop pathways. So the orbital frontal circuit connects the orbital frontal cortex with deep subcortical structures through closed loop pathways that feed on themselves. So look, the pathway layout it originates in the cortical region, right? In the orbital frontal cortex, behind the orbit in the frontal lobe, the cortex there, the lateral and medial subdivisions. Okay, we have those. The lateral orbital frontal cortex evaluates punishments and response inhibition, and the medial evaluates rewards. That's the orbital. Next is the subcortical relay, the ventral caudate nucleus, the ventral striatum. These structures integrate emotional and motivational information. Okay, so the cortex, then the subcortical lesions, then the pallida and thalamic relay, globus pallidus and terminus, substantia nigus, pars reticulatus, and medial dorsal nucleus of the thalamus. Okay, then path now to the, okay, great. So see, eventually goes from this to the thalamic. And so the point is to go from this orbital cortex, to go from this cortex to the relay center to the thalamus. And then from the thalamus, it turns back to the orbital frontal cortex. Okay. The orbital frontal cortex circuit regulates adaptive behavior based on emotional and reward regulated cues. Dry mouth. Okay. So in terms of reward evaluation, the functions of the orbital cortex evaluate rewards, decision making, again, impulse control, emotional regulation, social behavior. And so when people have behavior or disruptive behavior or impulse control issues, you sort of start thinking about this network here. And so let's look here. The neurotransmitters and receptor profiles. The orbital frontal network has a rich and diverse receptor environment, reflecting its role in integrating emotions, motivations, and cognitions, right? Look, here's a story again. Dopamine. Look, there's another story. Glutamate. There's another story. GABA, same thing. And then you have serotonin and norepinephrine. And look, endocannabinoids right here. Endocannabinoids, right? Reward and sensitivity. Now, it's the first time we've seen this cannabinoids sort of like receptor pop up here, But so here with dopamine, the D1 and D2 receptors, this is for reward processing, learning, feedback, salience detection. All right. Serotonin, here's the serotonin 5-1A, 5-2A, 5-2C, right? For impulse control, mood stabilization, aggression regulation. Yep. Then we have GABA, GABA A and GABA B is for inhibitory tone. It regulates impulsivity and noise filtering, right? Look, GABA inhibitory tone regulates impulsivity because it shuts things off. Glutamate, remember, activation. NMDA, AMPA, and then this other one here. This is excitatory drive for decision making and value encoding. Noradrenaline, that is the alpha and the beta receptors, arousal, attention, emotional reactivities, the endocannabinoids, C1 and the opioids, the hedonic tone, whatever it is, reward sensitivity. And so the dopamine receptors, you can use the antipsychotics to target the dopamine receptors. For the serotonin and noradrenaline, you can also use the second generation or atypical antipsychotics that will target both D1, D2. It'll start as serotonin, and it'll target norepinephrine receptors. Now here, GABA, benzodiazepines, right? Also Depakote and lithium. And glutamate, excitatory, definitely. Glutamate, Depakote and lithium, Depakote and lithium causes down regulation of glutamate receptors and up regulation of GABA receptors. So if you want to target this pathway, Depakote and lithium would be a combination of medications that can address these issues on this pathway. Again, and then endocannabinoids, cannabis, right? I would consider having a patient use cannabis and everything to help with these symptoms to stabilize this pathway. I think you can just look at the patient's symptoms and see like what clusters they start to fall in to sort of get a good idea of the neurotransmitter dysfunction. And if you get a good idea of the neurotransmitter dysfunction, then you want to pick a medication or two that addresses that dysfunction to try to get around the block that's happening right there. Makes sense? Okay, next, lesions or dysfunction effects. When the orbital frontal circuit is damaged or dysregulated, hallmark symptoms emerge that reflect disinhibition and emotional discontrol. Disinhibition and emotional discontrol. Domain behavioral disinhibition, that is, inappropriate jerks, sexual comments, impulse spending, risk taking. Yep, emotional lability, that is, rapid mood swings, irritable, a lack of empathy. That is poor judgment, inability to learn from punishment, persisting and maladaptive behavior. Look, social inappropriateness, loss of tact, disregard for the rules of others' feelings, obsessive compulsive traits, repetitive behaviors or overvaluations of certain rewards. Like, yeah, so lesions or dysfunction, look, behavioral disinhibition, right? Look, emotional lability, poor judgment, social inappropriateness, obsessive compulsive traits. Remember, so this happens really in head injury. So you get a head injury and damage to your orbital frontal circuit. Here, correlates orbital frontal syndrome, that is disinhibition, which is a type of frontal lobe syndrome. Yeah, disinhibition, addiction, right? Maladaptive reward learning, OCD, overactive orbital frontal striatal loop. You lose the brakes on the orbital frontal striatal loops for OCD. Mania impulsivity, elevated dopaminergic tone in the orbital frontal cortex striatal network can result in mania and insensitivity. Look, elevated dopaminergic tone, meaning dopaminergic hyperactivity, means this network is going to be hyperactive, right? If the network is going to be hyperactive, then everything's going to be turned up. So you're going to get the mania with the increased dopamine is going to cause the increase in release of glutamate. And once glutamate is released, everything is turned on, and the whole thing just explodes from there. Look, depression due to reduced activity in the medial orbital frontal cortex. You see, when the network is hypoactive, meaning if this has deficits in serotonin or deficit in norepinephrine, then you may want to use an antidepressant, a SNRI like Effexor or Cymbalta or I forgot the other one. That targets both serotonin and norepinephrine, or you can use an atypical antipsychotic because it's going to target dopamine here, it's going to target serotonin, and it's going to start norepinephrine. You may need to use the mood stabilizers that down-regulate glutamate and up-regulate GABA. And so when you look at these symptoms, you can sort of get a good idea of how to use the combination of medication, sort of target what you need. Okay, summary here features a core cortical origin, orbital frontal cortex, subcortical structures, the ventral caudate, nucleus accumbens, and pallidum and thalamus. The major function is emotional regulation, reward-based decision, and impulse control. Key neurotransmitters, dopamine, serotonin, GABA, glutamate, damage, disinhibition, impulsivity, social inappropriateness, labability. Would you like a diagram or visual map of orbital frontal subjects? Yeah, let me go ahead and see. Let me go ahead and see what they put together. It may take a minute for this to. Yeah, it's going to take a minute. And it's going to be a general diagram anyway, so I don't think it's going to really help us with anything. I think that's all I have to say now about the remember, when you start seeing patients and looking at the cluster of symptoms, you can start thinking about it in terms of, hey, what network is this failing here? The person seems to be very impulsive. They may seem to be making very poor decisions. Socially, they seem to be somewhat impaired, right? That may be this frontal lobe deficits, right? Start thinking about the tracks that go through the frontal lobe, like the orbital frontal cortex. I hope this is helpful for you. Please feel free to like, subscribe, and share. And otherwise, it's been a pleasure talking to you. Take care, guys. Read out. Ciao.